Hello guys, welcome back to my channel Gamma Die Gamma. So in the previous video, I actually started solving the ISC Math board exam 2020 paper, and we did the first 7 questions of section A. So that's basically half of the majority component of the paper, which is section A. So let in this video, let's do the other half from questions 8 to 14. So let's get started as always. Okay, so question 8 has you can choose from uh, part A and part B. You have to do either one. You can do either one. So, anyways, we're gonna do both just like my previous video. So, question 8, part A, option A rather, says evaluate this integral. Okay, so this integral is 1 over square root of quadratic, and the dominant term, or basically the coefficient of x squared, has a negative 4 on it, and we don't like that because the coefficient of x squared should have um, the coefficient of x squared should be 1 in an ideal case. So what I'm going to do is I'm just going to write this as it is. Okay, so we can actually factorize out a positive coefficient from the entire denominator, but we have this negative and we can't factorize a negative outside this square root because uh, that will be like multiplying by square root of -1, which is I. And since this is like high school calculus, we don't deal with complex numbers. So what I'm going to do is I'm going to have dx over square root of, just take a negative like this, then you flip the order, 4x squared minus 5x, like that. And that's under root. Okay, fair enough. Now I would like to take 4, factorize that out. So we have -4 roughly, and then we have x squared minus 5x over 4 because we are factorizing that 4 out. Okay, so square root of 4 becomes 2 and it becomes half outside. Then dx over square root of negative x squared minus 5x over 4 under root. Okay, so now what I'm going to do is use a classic method of completing the square in the denominator. So for completing the square, I need to divide 5 over 4, the coefficient of x, by 2. We get 5 over 8 and square that. So we have um, 25 over 64. So I will have to add and subtract this 25 over 64. So negative outside as it is, x squared minus 5x over 4 plus 25 by 64 minus 25 by 64. Okay, so we have half dx over, look at these 3 terms. We can write them as x minus 5 over 8, the whole thing squared, and this negative negative will become a positive 25 over 64. So we have half an integral of dx over 25 over 64 is 5 over 8 whole thing squared minus x minus 5 over 8 the whole thing squared. So this is basically our integral, and we actually had a formula for this under root. I'm forgetting the root every time. Yeah, and we had actually a formula for this. This is actually related to an inverse sine function. You could do a trigonometric substitution over in this case, but I'm just gonna spare you the pain of using the u sub and everything, because I'm assuming that you guys are fluent with some common antiderivatives of this form, of the form, say dy over a squared minus y squared. If you don't know this, this is inverse sine of y over a plus c, where a is some constant. We have similar thing here. So we have half times inverse sine of this x minus 5 over 8 divided by 5 over 8 plus c. That becomes half of sine inverse of, take the LCM quickly, we have 8x minus 5 over 8, and that 8 cancels out, giving us just a 5 in the denominator, plus c, and that's your antiderivative. Okay, so now let's do option B of question 8 still, and it seems it's also another integral. So question 8, option A was an integral, option B is also an integral. So question 8 just won't allow you to escape integration. That's why it's a really nice idea to not skip integration when you're studying for your exam. So anyways, let's call this I, integral of sine cubed x times cosine to the fourth power of x dx. um, okay, so what are we going to do? Notice that sine is raised to an odd power, and if you're familiar with these kind of trigonometric expressions raised to powers multiplied with each other, then you might know that break up the trigonometric function raised to odd powers. In this case, that's the sine, and you break it in such a way that you have even sine squared x times cosine to the fourth times sine x. So this sine x and this sine squared will make a sine cube like we had before. And why was this useful? Because now we can write this sine squared as 1 minus cosine squared x, and this cosine to the fourth of x as it is, and then sine of x dx. And now noticing that sine of x, or negative sine of x at least, is the derivative of the cosine. So make a u substitution. Let u equal cosine of x such that du is negative sine x dx. So I now becomes, take a negative outside to compensate for the du, 1 minus u squared u to the fourth, and this entire thing, because we took a negative to compensate for that, will become du. And that's the advantage of splitting up these things like this. So we have um, u to the u squared times u to the fourth is u to the sixth minus u to the fourth. All of that is still integrated du. And this is easy. This is u to the 7 over 7 minus u to the 5 over 5 plus c. But don't forget to back substitute. U is cosine of x. So this will be cosine to the fifth power of x. Sorry, seventh power divided by 7 minus cosine to the fifth power of x over 5 plus c. That's your antiderivative. Okay, so finally moving on to question number 9. It says solve the differential equation 1 plus x squared times dy over dx is equal to 4x squared minus 2xy. And if you want to do some scratch work, you can. If you want to check if this is a variable separable, you can do it if you maintain like a rough column or something. But notice that this negative over here and also this positive to a great extent prevent it from being a variable separable. So it's not variable separable. So what are we going to do? Well, notice that there is a singular y here. There is a singular y here. So it's actually a hint for linear in y. We have a hint. Now let's check if it fits the boot. Okay, so to check if it's linear in y, we need to just separate the dy over dx first. So dy over dx is equal to, divide by 1 over x squared on both sides, 4x squared divided by 1 plus x squared minus 2xy over 1 plus x squared. Now take the negative term because that contains a y on that side. So dy over dx plus 2x over 1 plus x squared. I'm going to write that entire thing multiplied with y is equal to 4x squared over 1 plus x squared. And this actually fits the form dy over dx plus p, which is a function of x multiplied with y, is equal to q, that is a function of x. So notice that p, that's a function of x, is nothing but this part, 2x over 1 plus x squared, and q, that is a function of x, is nothing but this other part, 4x squared over 1 plus x squared. And this is actually the form of a linear in y differential equation, and it actually fits. So this differential equation is linear in y. And so for that, for equations that are linear in y, we need to find an integrating factor now. That's given by e raised to the integral of p, which is a function of x, dx. But we know p of x, right? So e raised to integral of 2x over 1 plus x squared dx. And integrating this is easy. We have e raised to the natural log of 1 plus x squared, because 2x is a derivative of 1 plus x squared. So you can just do a quick use substitution, you'll get this. Now, by properties of exponents, we'll just have 1 plus x squared. The e and the natural log cancel out. Fair enough, that's the integrating factor. Now, the general solution to our differential equation now becomes y times integrating factor is equal to integral of q, which is a function of x, multiplied with the integrating factor dx, and add a constant of integration c. That's the general solution to our differential equation. So y multiplied with the integrating factor, which is 1 plus x squared, and then indefinite integral of q of x, which is 4x squared over 1 plus x squared, multiplied with integrating factor, which is 1 plus x squared, dx plus c. So notice the denominator and the numerator here cancel out. So if y times 1 plus x squared is equal to antiderivative of 4x squared dx plus c, and trust me, this is the easiest antiderivative you can get. So y times 1 plus x squared is equal to 4 over 3x cubed plus c. And since no initial conditions were given to us, this is the solution to our differential equation. If you want to isolate the y, you can do that, but I'm just not going to do that now. Okay, so finally moving on to question number 10. The question says, three persons A, B and C shoot to hit a target. Their probabilities of hitting the target are 5 over 6, 4 over 5 and 3 over 4 respectively. Find the probability that 1, now it has two subparts. 1, exactly 2 persons hit the target, and subpart 2, at least 1 person hits the target. So now what we're going to do is we're going to start with what's given to us, basically converting the problem from words to mathematics. So we have 3% hitting a target and probabilities of each of that event occurring is given. So P of A, let's call that probability that A hits the target is 5 over 6. Okay, we'll write it in this way. And then probability of B hitting the target is given to be 4 over 5. And probability that C hits the target, P of C, is then 3 over 4. Fair enough. Okay. Now let's look at one. So exactly 2% hit the persons hit the target. So for 2 persons to hit the target, okay, so for 2% to hit the target, let's call that P of exactly 2% hitting the target. So let's write that as this is equal to, that happens when A hits the target and B hits the target and C doesn't hit the target. This is a complement, by the way. Or other possibility, so for or we add, in the event that A doesn't hit the target and B hits the target and C hits the target. So again two people hitting. Or so add another scenario where A hits the target, B doesn't hit the target this time, and C hits the target. And since all of them are independent events, in questions like these, there are independent events. And one great thing of independent events is, say, probability of A intersection B is equal to probability of A multiplied with probability of B, and that happens when three things are also in intersection. So probability of A intersection B intersection C complement will be probability of A, probability of B times probability of C complement plus probability of A complement, probability of B, probability of C plus probability of A, probability of B complement, probability of C. So just substitute stuff in. We have 5 over 6 times 4 over 5 times 1 minus 3 over 4. C complement is 1 minus probability of C, which is 1 over 4, plus A complement is 1 minus 5 over 6, which is 1 over 6 times 4 over 5 times 3 over 4 plus 5 over 6 times, this time 1 minus 4 over 5, 1 over 5 times 3 over 4. So now 4 cancels out, 5 cancels out, we have 1 over 6. 4 cancels out, 3 cancels with 6 2 times, and we have 1 over 2 times 5 is 1 over 10, plus 5 cancels out, 3 cancels with 2 6 2 times, 4 times 2 8, 1 over 8. If you simplify this, you get 95 over 240, which is nothing but 47 over 120. You can calculate the decimals of this thing easily to 3 decimal places. So that's subpart 1. Now subpart 2 is saying probability that exactly 1% hits the target. I'm sorry, I read it wrong. At least 1% hits the target, not exactly. So at least 1% hits the target. So P of at least 1. So that means the probability of greater than or equal to 1% hitting the target. So we can have, in the worst case, 1% hitting, and then after 1% you can also have 2 persons hitting, and then you can also have all 3 persons hitting. So that's basically like saying 1 minus probability of nobody hitting, because probability of, at least one person includes probability of one, probability of any two, and probability of all three. So it's basically the set that contains all the possible outcomes for three people except the outcome of nobody hitting the target. So we can have 1 minus probability of nobody hitting the target, because you know inst- if, because nobody and at least one will make the complete set of all possible outcomes. So if you remove, and the probability of a complete set of all possible outcomes is 1 if all the scenarios happen. So if we subtract probability of nobody from 1, then we'll get the remaining probability of 1, probability of 2, probability of 3, which is basically probability of at least 1. So I hope you understand the rationale there. It's actually not that hard if you think about it. So anyways, it's like sort of a well-contained set. So nobody is probability when A doesn't hit the target, B doesn't hit the target, and C doesn't hit the target. So we can have 1 minus probability of A complement, probability of B complement, probability of C complement, which eventually turns out to be 1 minus 1 over 6 times 1 over 5 times 1 over 4. And that turns out to be 1 minus 1 over 120, which is 119 over 120. And that's the required probability in the subpart 2. Okay, so they're saying solves the following system of linear equations using matrices. Okay, so and they've given us a set of three equations, the system of three equations. So x minus 2y is equal to 10, 2x minus y minus z is equal to 8, minus 2 plus z is equal to 7. So now let's just write them one below the other. So we have x minus 2y. There's no z, so 0z is equal to 10. Okay, and then we have 2x minus y minus z being equal to 8. And then we have 0 x minus 2y plus z being equal to 7. Okay, so this is our system of equations. And they're saying using matrices. So we have two options: Martin's rule or using Kramer's rule. So since Kramer's rule wasn't supposed to be in syllabus for year 2020, so let's ignore this for now and let's stick with Martin's rule, which is the one of the most popular methods of solving a system of equations using matrices. So now just looking at the coefficients, I'm going to determine a matrix A to be the coefficient of x over here is 1. So 1, and then coefficient of y is negative 2, and then coefficient of z is 0. And then, okay, look at the second equation now. Coefficient of x is 2, coefficient of y is negative 1, coefficient of z is negative 1. Okay, third equation, coefficient of x is 0, coefficient of y is negative 2, coefficient of z is 1. So call that A, matrix of coefficients, and capital X you define to be these variables, but you go in order. So this first column 1 to 0 all contains the coefficients of x in on the three systems of equations. So the first entry should be x in the first row, and then second column was y, so y here, and then z here, like that. Order is important. Okay, that's a and that's x. And what about these remaining, 10, 8, and 7? You call b, define that to be the column matrix of 10, 8, 7. So basically our system of equations can be represented by ax is equal to b. And you can check that, you can multiply stuff and you can check that. Okay, so now let's first check for the determinant of a, and I'll explain why in a brief minute. So determinant of a, look at this row 1. 1 times um, -1 minus 2, -1 minus 2, then minus minus plus 2 with 2 here as well, and then don't bother for 0 because 0 will anyways make everything 0. So this turns out to be -3 plus 4, which is equal to 1, and that's not equal to 0, which means A inverse exists and unique solution to the system of equations exists because A inverse exists. Now, because since A inverse exists, we showed that here. If we pre-multiply by A inverse on both sides, we'll have, this will become the identity. Identity times x is equal to A inverse times B. Identity times any matrix is that matrix itself. So x is equal to A inverse multiplied with B. Okay, so now let's calculate A inverse, and for that I'm going to have to write A again for our convenience. 1 to 0, -2, -1, -2, 0, -1, 1. That's A. And now let's actually start calculating adjoints for that. So A11, cofactor of entry 1, 1, cofactor of entry 1, 2 with a negative, cofactor in entry 1, 3, then cofactor entry 2, 2, 2, 1 actually, then 2, 2, then 2, 3 with a negative, and we have 3, 1, 3, 2 with a negative, 3, 3, like that. So for A1, this becomes -3, 1, 2 is +2, this is -4, this will be +2, this will be 1, this will be +2, this will be 2, +1, and 3. And in case you're wondering how to calculate this, so A11 is this entry, right? So you cover up that row, so you cover up this row basically, and you cover up this column, so the row and column of that entry, and you look at what remains. So this square remains here, right? And then you try to calculate sort of a determinant of, consider this to be like a 2 by 2 matrix, and then calculate the determinant of that. So that's this times this minus this times this. So -1 minus this -2 that we have will give us a -3. And so you do that for A12 also. So you take this entry, A12 is this entry, cover up the row, so same row but different column this time. So the remaining part will be this and this. So consider these two as a 2 by 2 matrix, calculate the determinant, and you go around with that. So basically A inverse is just 1 over determinant of A times adjoint of A, and this is actually the values of the adjoint. These are all the entries in the adjoint of A. And that's why we needed a determinant to be non-zero, because 1 over 0 is not defined, and determinant turned out to be 1. So 1 over 1 adjoint of A, this turns out to be, they plug these into the entries. So -3, -2, -4, 2 1 2, 2 1 3. 1 over 1 is 1, so A inverse is just -3, -2, -4, 2 1 2 2 1 3. So X is given by A inverse times B. So we can do that here. X is equal to A inverse times B. So this A inverse multiplied with B, which was basically 1087. And I'm assuming you're good at calculating a matrix product, which turns out to be 0, -5, and a -3. That's X. And what was X? XYZ, and that is equal to 0, -5, -3. So that means comparing entries, X is equal to 0, Y is equal to -5, and Z is equal to -3. And if you plug these values into our system of equations here, over here, you'll see that they satisfy all the three equations. So these indeed are unique solutions and are perfectly consistent. Okay, so moving on to question number 12. Again, it had two options, A and B. Let's do both. Option A, show that the radius of a closed right circular cylinder of given surface area and maximum volume is equal to half of its height. Okay, so first things first, we know it's a cylinder, a regular cylinder. So draw that up. Okay, so consider this to be your cylinder, for example, of a given surface area. So the surface area, called that A of a cylinder, is given by the surface area of this top, of the both the tops. So if you call the radius R and the height H, we can get things done. So the area of both these circular tops, so pi r squared plus pi r squared is 2 pi r squared, and then this um, like sort of rectangular circular rectangle which is along the length, so it will be 2 pi r h, because we just want this surface like this. Okay, and we can do some simplifications here. So h will turn out to be A over 2 pi r minus r. And these are useful because they're telling us to maximize the volume. So we need a volume function V. Volume of this thing is pi r squared h, and we need to maximize this, so we need to differentiate with respect to one variable, and we have two variables r and h. So we want one variable, so write h in terms of r, and we have a substitution for h. So substitute that, pi r squared times A over 2 pi r minus r. Volume is therefore A pi r squared over 2 pi r minus pi r cubed, which becomes ar over 2 minus pi r cubed. And now we can differentiate with respect to r on both sides. So when we do that, we have a is a constant, right? They're saying given, so it's a constant, it's a fixed value, we can't change that. So we'll have a over 2 minus 3 pi r squared. And this, if we need a maximum volume, which means the derivative of volume with respect to any variable should be set to 0 for maximum or minimum. We'll check for if it's a maximum or minimum. So this means 3 pi r squared is equal to a by 2. Area is 6 pi r squared. If you plug that back into this formula, you'll get 6 pi r squared. This can be actually expressed as 2 pi r times r plus h. So we can use that now. 6 pi r is equal to 2 pi r times r plus h. So we have, stuff will cancel out. 3r being equal to r plus h. H is equal to 2r, implying r is equal to h by 2. And this is really exciting because we had to show the radius is equal to half of its height. So yeah, radius of this is half of its height, but we still need to check whether this is the point of maximum or minimum. We just said maximum volume, right? So let's take the second derivative. So we use dv over dr, which turned out to be a over 2 minus 3 pi r squared. Again, second derivative, d2v over dr squared. This will go to 0. We have negative 6 pi r. R will always be positive, it's a radius. 6 pi are always positive. So entirely this term will always be negative because of the negative up front. So if the derivative is 0 and the second derivative at that point turns out to be negative, then that point is a point of maximum. So this indeed happens when we have maximum volume. We just check that with a second derivative test. So hence proved, we showed that radius is half of the height. Hence proved, QED. Okay, so question 12, option B. We need to prove that the area of a right angle triangle of given hypotenuse is maximum when the triangle is isosceles. So for actually starting this question, we need to draw a right angle triangle because we need to start from there and then somehow come to the special case of it being isosceles when the area is maximum. So let's draw a right angle triangle, a regular right angle triangle. We've been used to drawing since trigonometry class. Okay, call one side x, call the other y, and the hypotenuse, call that h, is equal to square root of x squared plus y squared by Pythagoras theorem. Okay, so we basically have h squared minus y squared being equal to x squared, right? And hypotenuse is a constant, given hypotenuse. And so we need to maximize the area. So we need to define an area function, a function we need to maximize. What's the area of this? Half into the length of the base, which is y, and the length of the height, which is x. Half into base into height, basically. Okay, but we need to maximize this. So we need to differentiate area and set it to 0. But we have two variables. So let's write y, let's write x in terms of y. So from this we have x is equal to square root of h squared minus y squared. So we can use that. Area is equal to half y times square root of h squared minus y squared. So now differentiate with respect to y, we have dA over dy being equal to half can be taken outside. Then the product rule on these, square root of h squared minus y squared minus 2y squared over 2 times square root of h squared minus y squared. You can do this on a piece of paper if you have don't agree with my calculations. And now set that to 0. So we have half of square root of h squared minus y squared minus y squared, the 2's cancel out, over square root h squared minus y squared is equal to 0. Half can be thrown on that side. We have taking an LCM, h squared minus y squared divided by square root of h squared minus y squared being equal to 0. And since this square root of h squared minus y squared is always positive, you can throw that on that side. It will never be 0, right? Because h squared minus y squared is basically x, and x can't be 0, otherwise you'll just have a line if this side just collapses down. This can never be 0, so you can just throw it on that side. We have h squared minus 2y squared being equal to 0. So substitute for h squared, x squared plus y squared by Pythagoras theorem, minus 2y squared is equal to 0. So stuff will cancel out. We have x squared is equal to y squared, implying that x is equal to y, because you can't take the negative branch of when you root both sides. Their lengths, that's why. So x is equal to y. So this length is equal to this length. And that's actually enough to show its isosceles, but we actually need to do some more work, because we need to show this is actually the point of maximum. This happens when it's maximum. The area is maximum. So we need to do the second derivative test. So dA over dy, I'm recalling the function, is 1/2 square root of h squared minus y squared minus y squared over square root of h squared minus y squared. Now differentiating both sides with respect to y, again we have d2a over dy squared. We have half negative y over square root of h squared minus y squared. I'm doing this quickly. Minus 2y times square root of h squared minus y squared plus y cubed over square root of h squared minus y squared divided by h squared minus y squared. But the thing is, we can use this information that we have to just specify it that it's this point. So we can use the information that h squared minus y squared is equal to y squared from this equation, because x squared was h squared minus y squared, and y squared is just y squared. So when we use that information here, plug that in, negative y over y, actually we can take the negative outside. We have a plus here as well. We plug that in, we have 2y squared plus y cubed over y, which is y squared, divided by y squared. So stuff cancels out. Negative half, this is 1, and this is 3, I think. Yeah, 2 plus 1, 3, which is 4, is negative 2, which is less than 0. Therefore this point where x equals y is point of maximum. We showed that with the second derivative test, and showing this is really important because we can confuse it with a point of minimum and then get this answer. So x equals y, so this side is equal to this side, two sides equal, it's an isosceles triangle, hence proved. QED, just like we had to. Okay, so we have question number 13, which is a bit like question number 8 because it has options, but both of them are integration, so you can't escape integration, boys and girls. So let's just start by calling this I is inverse tangent of square root of 1 minus x over 1 plus x dx. So noticing the 1 minus x and 1 plus x inside an inverse tangent, if you're really fluent with your double angle formulas for the cosine, you might know that letting x equal cosine 2 theta is going to help, is going to do wonders, because dx will be negative 2 sine 2 theta d theta. So I is nothing but inverse tangent of square root of 1 minus cosine 2 theta over 1 plus cosine 2 theta with a negative 2 sine 2 theta d theta. So we have negative inverse tangent of 1 minus cosine 2 theta is 2 sine squared, half the angle, so 2 theta over 2, which is theta. And denominator, we have a similar thing but with a cosine squared theta, and 2 sine 2 theta d theta as it is. So now this will just simplify to sine squared theta over cosine squared theta, which is tan squared theta under root, which is regular tan theta, and 2 sine 2 theta d theta. So the tan inverse of tan is just a theta. Take the 2 outside with 2 theta sine 2 theta d theta. And it looks like we can perform integration by parts on this. So the antiderivative of negative 2 sine 2 theta is cosine 2 theta. So theta as it is cosine 2 theta minus integral of cosine 2 theta, and derivative of theta with respect to theta is 1. So ignore that. We have theta times cosine of 2 theta minus, this will become sine 2 theta over 2 for the coefficient, and add c. Now back substitute everything. Theta was cosine, well, let's see, cosine inverse of x over 2, yeah, that was theta. So we have cosine 2 theta is, if I'm not wrong, just a regular x, and this 2 is x over 2 times cosine inverse of x minus square root of 1 minus x squared over 2 plus c. That's what I turns out to be. Okay, so moving on to option B of question number 13, which is happens to be the penultimate question of this video. So anyways, we have to evaluate this integral. Fair enough. Call that I, 2x plus 7 divided by x squared minus x minus 2 dx. So notice we have a linear divided by a quadratic, so we can actually try to mimic the derivative of the denominator on top. So the derivative of the denominator is 2x minus 1. So we can try to create that 2x minus 1 over x squared minus x minus 2 dx. But we had a 7, so we need to add 8 to maintain equality, plus 8 dx over x squared minus x minus 2. Okay, so you can do some u substitution, but if you have a derivative of the denominator in the numerator, then this becomes the natural log of the denominator, which is x squared minus x minus 2. Plus we'll have 8 times integral of dx over x squared minus x minus 2, and looks like we'll have to complete the square over here like a good old fashioned way. We have 8 dx over coefficient of x squared is 1, so no, don't need to bother like question number 8. So this will be x minus half the whole thing squared minus 9 over 4, which if I'm not wrong, you can check that out if you want. Natural log of x squared minus x minus 2 plus 8 times integral of dx over square root, no, there's no square root, sorry, x minus half squared minus 3 over 2 whole thing squared. We have natural log of x squared minus x minus 2 plus, and there was a formula for this which involved natural logs. You can do partial fraction decomposition here using difference of squares in the denominator. I'm not going to do that, it's a lot of effort for nothing. So we have 8 over 2 times whatever this constant was that was squared. So 2 times 3 over 2 is 3 times natural log of this x minus half minus 3 over 2 divided by x minus half plus 3 over 2 plus constant of integration c. So we have natural log of x squared minus x minus 2 plus 8 over 3 times natural log of, this will simplify to x minus 2 over x plus 1 plus c, and that I believe is our answer. Everything is in x. Yeah, we successfully evaluated it. Congratulations. Okay, moving on to the last question, question number 14, and oh god, it's a piece of work. I mean, looking at this page, you probably might have guessed this like the longest and the most rewarding question for 6 marks. Anyways, question number 14, here we go, which says the probability that a light bulb produced in a factory will fuse after 150 days of use is 0.05. Find the probability that out of 5 such bulbs, none will fuse after 150 days of use. That's subpart 1. 2, subpart 2, not more than 1 will fuse after 150 days of use. Subpart 3, not more than 1 will fuse after 150 days of use. And subpart 4, at least 1 will fuse after 150 days of use. Okay, so first things first, noticing that we have a probability and a number of such bulbs. They've given a probability of 1 bulb fusing, and they've given us 5 such bulbs. So this is actually hinting us to use a binomial distribution in probability. There's like a big, it's like a big part that comes in the end of probability, which might seem counterintuitive to few, but it's really powerful. So they've given us the probability. So call that P, probability that a bulb will fuse, 1 bulb will fuse, is given as 0.05, and the Q is P complement, which is 1 minus P, is 0.95. Bulb will not fuse. Okay, so and they've given us 5 such bulbs, so call N 5 the number of samples, you can say, or number of times this experiment is carried out. And the formula for this is, say they want to calculate the probability of some x number of bulbs fuse. In this context, x is number of bulbs that fuse. Then the formula is n choose x q to the q raised to n minus x times p raised to x. So that's basically what we're going to use again and again. So for non-fusing, x is 0, right? So according to this formula, we have phi choose 0. You can write this lower subscript in front of the C, or behind it, like I've done. Up to you. We'll have Q, which is 0.95 raised to phi minus 0, which is phi, and P, which is 0.05 raised to 0, which will be 1. So ignore that. Phi choose 0 just turns out to be 1. So our probability is 0.95 to the fifth power, which is really, really small. And you can find decimals, but I think your calculator will just give up. Anyways, then they're telling us to find not more than one will fuse. So probability of not more than 1. So in the worst case 1. So probability of less than or equal to 1. So that equals probability of 0 and the probability of 1. Probability of 0 we calculated out to be 0.95 to the fifth, plus probability of 1 will be phi choose 1, 0.95 to the phi minus 1 or fourth power, and 0.05 to the first power. So this will be 0.95 to the fifth plus phi choose 1 is phi times 0.05 times 0.95 to the fourth power. Okay, sub part 3. As I said, I'm not going to calculate all the decimal points. More than one will fuse after 150 days. So more than one. So probability of more than one, which to write in terms of inequalities, will greater than 1. So we're not including 1. So this will be 1 minus probability of not more than 1, right? This set is inclusive again, all encompassing. So 1 minus 0.95 to the fifth minus, we just use the subpart 2, 5 times 0.05 times 0.95 to the fourth. Subpart 4. At least one will fuse after 150 days of use. At least one. So probability of at least one. Probability of greater than or equal to 1. Okay, so greater than or equal to 1. So which means the set of all minus, you subtract probability of none from that. Probability of 0. So 1 minus P of 0, none fusing. So 1 minus 0.95 to the fifth power. And that's it. We're done with question number 14. So hey guys, please like, share and subscribe to my channel. Recommend me to your friends. I'm really putting in a lot of work in terms of planning, writing, execution and all stuff. Recording, editing too. So please, I really want more subscribers. I hope we can reach 100 in the next couple of weeks. And in the meantime, keep doing math, stay home, stay safe, and peace out. Oh, and by the way, stay tuned for my next video. I'm going to do section B. We finished section A. I'm going to do section B, and section B is quite unpopular with people. People don't usually attempt that. I didn't, for a matter of fact, but I gained more insight during the vacation when I studied linear algebra and other topics. So I'm going to provide an original solution to section B. So stay tuned for that, please.